Hello everyone and welcome to STEM School. So in today's video, I'll be explaining everything about the graphs of quadratic functions. I'll explain the different features of the graph and also explain other useful theory you could be asked about in the exam. So there's plenty to do, and before I begin, as always, please do remember to like the video and consider subscribing to the channel. That will be fantastic. Alright, let's get started. So hopefully you'll have seen quadratic equations before. Well, a quadratic function is literally the same thing, okay? So don't get confused. It's just a function that contains an x squared term with no higher powers. So a quadratic equation, we'll take this form here. You'll have seen this before. Y is equal to ax squared plus bx plus c. So you have the x squared term, then you have the x term, and then you have the number on the end there. But what you'll see more in this topic is something called function notation. That's when you replace the left hand side y with something like f of x, okay? So f of x is equal to ax squared plus bx plus c. Okay, so you just treat it like the same thing. It can be g of x, it can be h of x, okay? So that's a typical form that you'll see of function notation, okay? So we'll do some examples so you can easily identify what a quadratic function is, or quadratic equation. They're the same thing, okay? So first of all, we have, y is equal to x squared plus 2x minus 3. Okay, so this is a quadratic equation because we've got the x squared term, we've got the x term, and then we've got the number on the end there. Okay, so that's easy enough. Let's do another one. So we have y is equal to 4x squared plus 4. So this looks a little bit different, okay, but this is actually a quadratic equation. How do I explain it? So what you can easily write this as 4x squared plus 0x plus 4, okay? So this is a quadratic equation, but in this case the x has a 0 in front of it, the x term has a 0, okay? So let's do another example. We've got y is equal to x squared, okay? This is the simplest quadratic equation you can get. Why is this a quadratic equation? Well, if you look at it like this, so we have x squared plus 0x plus 0. Okay, so as long as the function itself contains an x squared term, then we have a quadratic equation, okay? So now what I want you to appreciate is that this quadratic equation is a curve on a graph. In the same way, an equation of a straight line can be represented graphically. So the quadratic equation expresses the relationship between the x coordinates and the y coordinates that lie on the curve. So what does the curve of a quadratic function look like then? Well, it's something called a parabola, and it takes the form of this shape here. So this is the simplest quadratic curve you can get because we're using the simplest quadratic equation you can get. Y is equal to x squared. So you'll notice that the letter on the left hand side, that's going to be on the vertical axis, and then the other letter, that will be on the horizontal axis. So we have x here, okay? So obviously you'll need to get used to function notation, so you could be given the function f of x is equal to x squared. So in that case, whatever's on the left hand side will be on the vertical axis, f of x, okay? So you see this xy graph very often. Now, when it comes to the graphs of quadratic functions, a common question you could be asked is to identify some key features. So what I'll do now is explain what are the key features you'll need to know about the parabola. So first off, let's do this point here. So this point here is called the turning point. So the turning point is basically a point on the parabola where the curve changes direction. So you'll notice that the curve moves down the way, then it reaches this point here, then the curve moves up the way, okay? So that's basically identifying a change of direction on the curve, okay? So on a related note, you can get different shapes of parabolas. You can get an upside down one. So the way to think about it is you can get a happy parabola and then you can get an unhappy parabola. So in this case, the turning point will be here, TP. So the curve moves up the way, then it reaches this point, and then the curve moves down the way like that. So you'll notice that the turning point occurs at the dead center. So of course it's a symmetrical shape, so you'll notice that it happens in the very middle, okay? Then on a related note, so another feature that you have to identify is something called the line of symmetry, okay? So a common question in the exam is to give the equation of the line of symmetry. So obviously if you have a symmetrical shape, you'll have a line of symmetry that you'll be able to mirror this shape on, okay? So you'll notice that the line of symmetry obviously happens in the centre and it occurs at the x coordinate of the turning point. Okay, so if you know the turning point, then you can find the line of symmetry, alright? So in this case, the equation of the line of symmetry will simply be x is equal to 1. Okay, so you'll notice it crosses at 1. Alright, so let's do another feature. So we have this feature here. So this is simply where the curve crosses the y-axis. This is just a common question that could be asked. And then lastly, we have something called the roots of the quadratic function, okay? So that's these 2 points here. Now these are two very famous points. So these are the points where the curve intersects with the horizontal axis. And I'll dedicate a whole video to this because calculating the roots of a quadratic function is a whole video in itself. But essentially, if you have a quadratic function, you basically just need to factorize it. You have to make it equal to 0 on the left hand side and then find the values of x, okay, using the various factorizing methods, okay. So these are the various features of the quadratic function that you need to learn for the different, theory questions for the exam, alright. Alright, so moving on to some more theory about turning points that you need to know. So what we need to know is that if the x squared term in the quadratic equation is positive, then you know the curve has a minimum turning point. So what do I mean by that? So the minimum turning point will look like this. So the parabola will be shaped like a happy face if you think about it like that. Now the other scenario is if the x squared term in the quadratic equation is actually negative. In that case, what we have is a maximum turning point. So the parabola will be shaped just like this, okay? So the turning point in this case will be here, TP for turning point. So the way to think about it is a positive x squared, we have a happy parabola, and then if the x squared is negative, we have an unhappy parabola just like that, okay? Right, so moving on to the next bit of theory that you need to know, and that's to do with the positioning of the parabola on an xy graph. So as you know, you can represent a quadratic equation just like this. Y is equal to x squared plus bx plus c. Now in this section, what we're going to look at is representing the quadratic equation in this form instead. So what we have is y is equal to x minus a all squared plus b. Okay doke. So this is a quadratic equation. It's just written in a different form. Okay. So don't get confused. This is still a quadratic equation. So you might actually recognize this form. So if you want to get from this form of the quadratic equation to this form of the quadratic equation, what you need to go through is the process of completing a square. Now, the process of completing a square is not so important to know for this topic, but if you do want to know how to do that process, I'll link a video explaining how to do that on the top right and also be in the description box as well. Now, it's pretty useful to represent the quadratic equation in this form, because what we can identify just by looking at this form is where the curve is going to be on an xy graph, and then also identify some other features immediately, okay? So first of all, let's look at these graphs here. So what we have here is an xy graph, and then we have the parabola of y is equal to x squared. Now y is equal to x squared is the most basic form of a quadratic equation. What you'll see, it's a happy parabola as we have a positive x squared, and then the turning point is a minimum turning point, and it's positioned at coordinates 0, 0. So what I'll do is I'll write this form of the quadratic equation just here, just for reference, alright? So what we're going to look at first of all is the letter A in this form, okay? So the letter A. So what we can say is that if the letter A is positive, then the parabola moves left, but alternatively, if the letter A is negative, then the parabola moves right. So for example, say if we had, A is equal to, I don't know, I'll make it 1. So A is equal to 1. So what we say is that if A is equal to positive 1, then it's moving left by 1. Okay, so it will just look like this. There we go. So as you'll see, the turning point is moved left by 1 unit. Okay, so the green one is A is equal to 1. But then what we can also do is we can do A is equal to minus 1. Okay, so if A is minus 1 is a negative, so that means the parabola is going to move right, and it's going to move right by 1 unit. So in that case, what we have here is a parabola looking like this. There we go. Okay, doc. So the letter A is just to do with the horizontal movement of the parabola, alright? So now what we'll do is we'll look at the letter B, okay? So if B is a positive number, then the parabola actually moves up, but if B is a negative number, then the parabola moves down. So obviously A is to do with the horizontal movement, and then the letter B is to do with the vertical movement. Okay, so let's do, we'll do B is equal to 1. Okay, doc. So if B is equal to positive 1, that means we're moving up the way, moving vertically up by 1 unit. So it'll look like this. There we go. So the turning point is moved 1 unit, okay? Now let's do another one. Let's do B is equal to minus 1. So in that case we have a minus number, so that means the parabola is going to move down the way, and it's going to move down the way by 1 unit. Okay, doc. And there we have it. Okay, so this is some theory that you need to know about positioning of the parabola. So just to summarize, the letter A is to do with the horizontal movement of the parabola, and then the letter B is to do with the vertical movement of the parabola. So we'll continue looking at this form of the quadratic equation, y is equal to x minus a all squared plus b. So as I just mentioned, by looking at this form of the quadratic equation, we can immediately understand the positioning of the parabola on an xy graph. Now in this section, what we can see is that by looking at this form of the quadratic equation, we can immediately identify the coordinates of the turning point and figure out what the equation of the line of symmetry is. Now these are typically asked in the exam, okay, so it's just some basic theory that you need to remember. So when the question in the exam gives you the quadratic equation in this form, what you can identify as a turning point is simply A, B as the coordinates, okay? So whatever the letter A is and whatever the letter B is, that's the coordinates, okay? So you just need to double check, be careful, that's x minus A all squared plus B, okay? So you have to get the negative and the positive in the right configuration, okay? Now the axis of symmetry is simply x is equal to a. So as you know, the turning point occurs at the dead center of the parabola. So the axis of symmetry is simply the x coordinate of the turning point. So it's x is equal to a. Okay. So if we move down here, what we have here is y is equal to x minus a all squared plus b. So this is a form that you should see in the exam quite often. So when you see this, what you can immediately identify is a minimum turning point, and the coordinates of the turning point will be a, b. So why is it a minimum turning point? So just a reminder, when the quadratic equation has a positive x squared, then you have a minimum turning point. So if you look at this equation carefully, this form, you'll still get a positive x squared. So that's a minimum turning point. And then the axis of symmetry is x is equal to a. Alright, now if we move to the right here, so this is a slightly trickier question that you could get asked in the exam. What we have here is y is equal to minus, and then bracket x minus a all squared plus b. So this is the same thing as a quadratic equation, but they throw in this negative here. So what's the effect of that negative? Well, it's just telling you that you have a maximum turning point. So why do you have a maximum turning point? So when the x squared term in the quadratic equation is negative, then you get a maximum turning point. So you just need to remember that fact. Okay, so the maximum turning point for this will be AB, same as before. Then the axis of symmetry is x is equal to a, same as before again. So what you just need to be careful as, you just need to memorize these two forms of the quadratic equation and just make sure you get the negative and the positive in front of the a and the b in the right format, okay? So what we'll do is we'll move on to some examples just to hone this idea in. So the first example is y is equal to bracket x minus 4 all squared plus 1. So when you look at this example, you can immediately identify some key features, okay? So when I look at this, I know it's going to be a minimum turning point, just like that. I know it's going to be a minimum turning point, and the coordinates is going to be, it will be 4, 1. Okay, doc. Because what we do is the 4 is going to be A, and then the 1 on the end here will be B. Okay, so this is basically the form A, B. Okay, so you just need to remember that fact. Okay, then let's move on to the axis of symmetry. So the axis of symmetry will be the x coordinate of the turning point. Okay, doc. axis of symmetry, well, that will be x is equal to a. So in that case, it will be x is equal to 4. Alright, so there we have it. So what will that look like? So the turning point will be 4, 1, so it'll be 4, 1. And then the axis of symmetry will be x is equal to 4. So it will just be like this. Alright, so we can just quickly draw it. Just like that. So we know it's going to be a minimum turning point because we have a positive x squared in the quadratic equation. So let's move on to this second example. We have y is equal to minus x minus 2 all squared plus 3. So this is thrown in that negative in front of it just to confuse you a little bit. But when you see this, what you know is that you have a maximum turning point. And then the coordinates is going to be, well, that minus 2 is going to be a, and then that 3 is going to be b. Okay, so what we have is the maximum turning point of 2, 3. Okay, so it'll look like that. Alright, so the axis of symmetry, we can easily figure that out. So that will be x is equal to a, so in that case it will be x is equal to 2. There we go. So let's quickly draw that. So we'll do a maximum turning point at 2, 3. So we have 2, 3 as a turning point, and then the axis of symmetry will be at x is equal to 2, just like that. Alright, so we can just quickly draw it like this. Okie doke, so that's how you can easily identify the coordinates of the turning point and also the axis of symmetry equation. You just have to remember some key facts here. So I just need to remember the quadratic equation should be in this form exactly, and then we can work out the turning points and the axis of symmetry from there. Alright, so let's have a go at some exam questions then. And what you'll notice at the top here is I've written some notes that you should remember because they summarise the key points that we've talked about in the video, right? So let's see what this question is saying. So we've been told to sketch the graph of y is equal to x minus 3 all squared plus 1. So when you're given the quadratic equation in this format, it should imply that you need to identify some key features like the turning point and the axis of symmetry and so on. So on our sketch, we have to show clearly the coordinates of the turning point and the point of intersection with the y-axis. So that's basically where the parabola cuts the y-axis, alright? So what we want to do is, first of all, write the quadratic equation that we've been given, x minus 3 all squared plus 1. And what you want to remember is that this is the form x minus a all squared plus b. So when you compare the two, you'll notice that you have a minus in the bracket and then you have a positive number on the outside there. So that's perfect, okay? We know how to easily work with that. So what can we easily identify when we look at this quadratic equation? So when I look at this, I can immediately identify it's going to be a minimum turning point. So why is it a minimum turning point? Because the quadratic equation contains a positive x squared term. Now what is the coordinates of this minimum turning point? Well, it's simply going to be a, b. So when you get given this, you want to label it like this. So the number on the inside will be a, and then the number on the outside will be b. Alright, so in that case, the coordinates for the turning point will be 3, 1. There we have it. Now, this question isn't actually asking you to mark the axis of symmetry, but you know, you can easily work that out as x is equal to a. If you remember that fact, it's just the x coordinate of the turning point. So in this case, it will just be x is equal to 3. Okay, doke. Now, the last part that we've been asked to do is to find the point of intersection with the y-axis. So just to quickly reiterate that when you have a quadratic equation, when you know the value of x, you can find the value of y. When you know the value of y, you can find the value of x, and vice versa, right? It's an equation describing the location of the coordinates, okay? So what we have here is y is equal to x minus 3 all squared plus 1. So if you want to find the point where the graph cuts the y-axis, well, that occurs when x is equal to 0, right? So what you want to do is substitute this value of x into this equation to find y. So let's do that. Y is equal to 0 minus 3 all squared plus 1. So what does that give us? Y is equal to, so minus 3 all squared, that will be 9 plus 1. So that will be y is equal to 10. So there we go. So our coordinates for where the parabola cuts the y-axis is simply 0, 10. Alright. So whatever coordinate you want to find, you just substitute the other value into the quadratic equation to find the other value, alright? So that's us found all the key points on this graph, so let's quickly draw that. So what you want to do is draw an XY graph like this, so just remember to label it, so X on the horizontal axis and Y on the vertical axis. So our minimum turning point is 3, 1, so I'll just put 3 then 1 just like that. So there's the minimum turning point. We have the axis of symmetry, x is equal to 3. It didn't ask for that, but we can just put that in anyway. So then we have where the parabola cuts the y-axis is 0, 10, just like that. So what we can do is just carefully draw the parabola like that. And there we have it. So all you have to remember is if you want to find, you know, a point of intersection with the y-axis, something like that, just remember that that occurs when x is equal to 0, okay? So remember x is equal to 0, alright? And lastly, we have this exam question here. So this question is telling us that the graph below shows a parabola with the equation of the form y is equal to x plus a all squared plus b. So if you look at this diagram, what we have is a parabola. It's a happy parabola. We have a minimum turning point. We've been told the axis of symmetry is x is equal to minus 5, and we've got this random point here on the parabola, minus 3, 8. So normally in these types of questions, we get given the full equation, full quadratic equation, but this time what we have to do is find the values of a and b. So first of all, what I want to identify is this form of the quadratic equation that they've given us, y is equal to x plus a all squared plus b. So typically in these types of questions, they try to throw you off with the general form of the quadratic equation. So we normally deal with this form here, y is equal to x minus a all squared plus b. Okay, so just what I would advise you is just ignore this. They're just trying to trick you out. So just stick to this form here, y is equal to x minus a all squared plus b. This form that they've given is correct because it's given a plus a in the bracket, and if you remember to earlier in the video, the letter a tells us about the horizontal movement of the parabola. So a positive a means the parabola moves left, which indeed it has, and then the positive b tells us that the parabola moves up. So it moves left and then moves up, okay? So just be mindful of that, just stick to this form here. So first of all, we've been asked to figure out the value of a. So the value of a. So how do we do that? Well, normally what we do is just look at the quadratic equation, but this time we've actually been told the axis of symmetry is x is equal to minus 5, okay? So normally what we do is x is equal to a for the axis of symmetry. So if x is equal to minus 5, that means a is equal to minus 5. Okay, doc. So we can actually sub that back into this quadratic equation. What do we have? We have y is equal to x, then we have minus 5 all squared plus b. So just be careful about the negative. So it'll be y is equal to x plus 5 all squared plus b. So that's a figured out, okay? So that's why you be careful with the double negatives, alright? So we figured out what a is. Now we need to move on to what b is. Okay, doc. So the question actually tells us that the point minus 3, 8 lies on the parabola, and we can calculate the value of b, okay? So how do we do that? So first of all, let's write what we know. So we know that y is equal to x plus 5 all squared plus b. So what we did is we found what a is, and we've substituted that back into the general form of the quadratic equation to get that, okay? So if you know a random point on the parabola, what we can do is just sub that back in to find the unknown. So we know the point minus 3, 8. What we can do is substitute minus 3 is x and 8 is y, because we have an x coordinate and then a y coordinate, okay? So normally you actually get told the turning point coordinates, but in this case we didn't. We just know a random point, okay? But it's the same principle. So let's substitute that back in. So we have 8 is equal to, so we have minus 3 plus 5 all squared plus b. So the only unknown in this case is b. So let's do that. So we have 8, so minus 3 plus 5, so that'll be 2 squared. so that'll be 2 squared plus b, so 8 is equal to 4 plus b, and that'll be, if you take the 4 to the other side, then it will just be b is equal to 4. Okay doke, so that's us figured that part out. So what's the full quadratic equation? We have y is equal to x plus 5 all squared plus 4. Okay, so the graph moves left by 5 units and then the graph moves up by 4 units. Okay, so that's the final quadratic equation. Okay everyone, so I hope this video has helped you understand the theory and exam questions on quadratic equation graphs. So join me in my next video where we'll continue this topic and look at calculating the roots of quadratic equations. Please like the video and subscribe to the channel, and I'll see you in the next video.